Here's problem 1212. A uniform 100-pound beam is held in a vertical position by a pin at its lower end and a cable at its upper end. A horizontal force, magnitude P, acts as shown in the figure. If P is equal to 75 pounds, what is the tension in the cable? Alright, so we're given pounds, and that's a unit of force. So we're using pounds just like we would use newtons if we were in the SI system. But we're using the British system with feet and pounds. No difference as far as how we would approach the problem. Alright, we want to do a free body diagram. We already have our force P given. And so this P is 75 pounds acting at this point. What are the other forces acting on this? Well, we have the weight of the beam itself, which acts at its center of mass, right in the center. And the weight of the beam is 100 pounds. It's acting straight down toward the center of the earth. We have a tension force acting along this cord. It's coming down like this, which would be a 30-degree angle from the horizontal in a downward direction. Let's break that up into two components. So this is our tension force. So we're going to have a component in the negative x direction, which would be t cosine 30. And then we'll have a component like this, which would be t sine 30 going down like that from this point. Alright, we have a reaction force at the pivot, which we don't know, but we will assign it vertical and a horizontal component to that. Now I got my h going to the left. I don't know for sure because in the x direction I've got a p and a t going on, so I don't know if h is to the right or to the left. If I come up with, if I solve for h and I come up with a negative value for it, then it should have been in the opposite direction from what I assumed, so it would have been to the right. Okay, that's no problem. Alright, so we want to find t. We're going to choose a pivot point right, or our axis right at the pivot point here. If we do that, we eliminate all the forces that have line of actions going through that point. So we would eliminate h from consideration. We eliminate v from consideration because its line of action goes through that point. We eliminate the weight of the beam because its line of action goes through that point. We would eliminate t sine 30 because its line of action goes vertical through that point. And things are a lot easier now. In other words, if we choose the pivot as our rotation axis, then looking at the beam, about that pivot, we really only have two forces. We've got a P force of 75 pounds acting with a moment arm of 5 feet, and then we have a T cosine 30 degrees acting with a moment arm of 8 feet. The T cosine 30 degrees is trying to make this thing rotate counterclockwise, which would be a positive torque, and the P 75 pounds with a moment arm of 5 is trying to make this thing rotate clockwise, which would be a negative torque according to the right hand rule. But it doesn't rotate, so the net torque is 0, so these two torques should add up to 0. So if I do the summation of all my torques about the pivot point, let's call it point A, that would equal 0. And so what do we have? We have a positive torque, which is moment arm of 8 times t cosine 30. And then we have a negative torque, which is moment arm of 5 times p. We want to solve for t. So t is equal to 5 times p. P is 75 pounds. So it's going to be 5 feet times 75 pounds divided by 8 times the cosine of 30. And I have 5 feet over 8 feet, so the feet units are going to cancel out. So this is going to give me an answer that is indeed in pounds. 5 times 75 divided by 8 times cosine of 30 gives me 54.1 pounds. So the tension in the cord is 54.1 pounds, and that's our answer. That's the tension in the cable.